Alright, welcome back everyone. Today we're going to talk about factoring and solving quadratic equations. So in this lesson you're going to learn what a quadratic equation is, how to determine if any kind of function is constant, linear, or quadratic, how to solve a quadratic equation by factoring and using the square root property, how to determine the x-intercepts of a graph. So when we talk about functions, we say a constant function is any function that's just equal to a number. So something like f of x is equal to 2. It's constant because it's always equal to 2. When we refer to something as a linear function, we're talking about it in terms of x to the first power. So anything that's written in terms of x to the first power is considered a linear function. A quadratic function is anything where x is written to the second power, so x squared. Now we can write other functions with even exponents in terms of quadratic functions, and I'll show you a little bit about that in just a moment. In general, however, the quadratic function can be written in the form f of x is equal to ax squared plus bx plus c. Now, a cannot be equal to 0. If a were 0, then the first term would be 0, and you would have a linear function. But b and c can be equal to 0. So let's see if we can determine if these functions are linear or quadratic. First one, 9.3x minus 12. And this is x to the first power. And so this one is linear. Negative 0.001x squared plus 2. And now we have x to the second power. And so this one's quadratic. And finally, 87x to the sixth. Well, that's not to the first power or the second power. But we can rewrite this, because it's an even exponent, as x squared to the third power. And because it's an even exponent, we can write it this way. It's quadratic in nature, even if it's not a quadratic function. So anything that's raised to an even power of x can be written at least in some form as a quadratic function. So a quadratic equation just takes the function and sets it equal to 0. Ax squared plus bx plus c is equal to 0. There are multiple techniques to solving quadratic equations. We're going to talk about 4 of them. 2 in this lesson and then 2 over the next 2 lessons. The ones we'll talk about in this lesson is factoring and the square root property. And then the next 2 lessons we'll talk about completing the square and the quadratic formula. Some methods are useful with some quadratic equations, but not all methods will solve every single one. The only one that works every time is the quadratic formula. The quadratic has real solutions, right? There's no i's. Then it gives the x-intercepts of the parabola, and we'll talk about that in just a few minutes, towards the end of this lesson. So, in previous classes, you should have had some experience factoring trinomials. Factoring trinomials just takes a quadratic and breaks it apart into linear multiplicative constituents. So what you're talking about is 2 linear functions that are multiplied together to give you 1 quadratic function. Now, most quadratic functions can be factored, but they aren't always conveniently able to be factored. In other words, you would have things like fractions, decimals. But in the case that these things factor to whole numbers, it's a lot easier to use factoring to solve a quadratic equation. Now, there are multiple methods to factoring. You may have learned it a different way than I'm going to show you. And there's nothing wrong with that so long as you get the right answer. Factoring, there are lots of different ways to do it. I'm going to show you the way that I do it. So first we're going to factor this trinomial. Assume that there's a 1 in front. And we're going to take the first number and the last number, and we're going to multiply them together. So 1 times positive 6 will just give us 6. Now that we've done that, we're going to make ourselves a box down here. And in the box, we're going to write the coefficient of x squared, which is 1, in both boxes. And we're going to split the x squared up so that we have x and x. Now, in the bottom part of the box, we need to find 2 different numbers. And those 2 numbers should add to negative 5, the number in the middle. So it should add to negative 5. And they should multiply to give you positive 6. That comes from the number that we found before when we first multiplied. So what we need are 2 numbers that add to give you negative 5 and multiply to give you positive 6. And so in this case, we can use negative 2 and negative 3. Negative 2 plus negative 3 is going to be equal to negative 5. And negative 2 times negative 3 is going to be equal to 6. So we're not quite finished. We want to factor this thing out. We want to write it as 2 components multiplied together. Had the coefficient of x not been 1, we would have had one more step to do, and we'll do that in the next example. But at this point, we have our answers. Our factors come from each side of the box. And so what we get is 1x minus 2 and 1x minus 3. And you can just rewrite that as x minus 2 times x minus 3. And now we've factored the trinomial. We've broken it apart into 2 things that multiply together to give us that function back. So let's try another example of factoring. So you can see what happens if the number in front is not a 1. The steps are still the same. We have 6x squared plus 2x minus 4. We're going to take the first number and the last number and multiply them together. 6 times negative 4 is negative 24. So down here we're going to make ourselves a box. We're going to write the coefficient of x in both places, so 6 and 6. And then we're going to split the variable up, x and x. And so now for the numbers on the bottom, we need numbers that will add to 2 and multiply to negative 24. And so if we have positive 6, and negative 4, and we add them together, we get positive 2. And when we multiply them, we get negative 24. Now, unlike the last problem, we're not quite finished here. When the number in front of x is not 0, or I'm sorry, when the number in front of x squared is not 0, there's one more step we have to do at the end. Each side of this box will reduce like a fraction. So we want to find what numbers will divide evenly into those that are in each side of the box. And they can be done independently from each other. So in other words, on the left-hand side, we have 6x plus 6. But they're both divisible by 6. So we're just going to divide them both by 6. 6 divided by 6 is 1. 6 divided by 6 is 1. On the right-hand side, we have 6 and negative 4. They're both divisible by 2. And so what we can do is we can rewrite this as 3x minus 2. And what we're left with is x minus 1, I'm sorry, x plus 1, and 3x minus 2. Now, if we multiply that back, we're not going to get 6x squared plus 2x minus 4. And the reason is, the problem that we started with, we could have taken out a common factor. They're all divisible by 2 from the beginning. And so if we divide each one of these by 2, or factor out a 2, then we get 3x squared plus x minus 2. Now, if we multiply those two terms together, we'll get what's in the parentheses there. So that 2, that common factor from the 2, matters if we want to multiply this thing back to get to what we started with. If you recognize that you can factor that 2 out from the beginning, then it saves you a bunch of trouble. It makes things easier. You likely don't have to reduce at the end, or you likely can't reduce at the end. But if we're just solving quadratic equations, which is what this thing is focused on, then that 2, as you'll see, won't matter. And so we could have just factored it the way we did and used that answer. So now we just want to talk about solving quadratics by factoring. Right, so we have a principle here, it's the principle of zero products, that says if you have two numbers a and b, and you multiply them together and they're equal to 0, then either a has to be equal to 0, b has to be equal to 0, or they're both 0. So when we want to solve quadratic equations by factoring, we want to move all the terms to one side of the equation so that one side equals 0. We're then going to factor out any greatest common factors, or any common factor between all the terms. Then we're going to factor the overall quadratic, like we just did in the past two examples. From that, we'll take both the remaining linear functions, set them equal to 0, and solve them, and that will give us our two answers. Okay. Quadratic equations will always have two solutions. In fact, the number of solutions is based on the highest power of x. So a linear function has, a linear equation has one solution. A quadratic equation has two solutions. If we had a problem that was x cubed, it would have 3 solutions. If it was x to the 4th, it would have 4 solutions. So let's practice some of this. In this case, we have the quadratic already factored for us. There's no need to multiply them back together and then refactor. All we have to do is take both pieces and set them equal to 0. And so we get 5x minus 2 equals 0. And 2x plus 3 is equal to 0. Over here, if we add 2 to both sides, we get 5x equals 2. And divide by 5, we get x equals 2/5. Over here, if we subtract 3 from both sides and divide by 2, we get x equals negative 3/2. Those are our two solutions to this equation. Let's try another one. Find the zeros of the given function. Anytime a question asks you to find the zeros of the function, what that means is for you to just set it equal to 0. When is the function equal to 0? And so what we're doing is we're going to take x squared minus 8x minus 20. We're going to set it equal to 0. Then we can use factoring to solve this quadratic equation. Once again, we take the first number and the last number, but the first number is 1. We multiply them together and we get negative 20. We're going to make ourselves a box here. Write the coefficient both times, and then split up the variable x and x. We now need two numbers that add to give you negative 8 and multiply to give you negative 20. And so, negative 10 and positive 2. Negative 10 plus 2 will give you negative 8, and negative 10 times 2 will give you negative 20. And so now we have our factors. X minus 10 and x plus 2. All right, remember they come from both sides of the box. So 1x minus 10, 1x plus 2. I just left that 1's off. And that's still equal to 0. So now it's just like the example we just did. We're going to take both pieces and set them equal to 0. X minus 10 equals 0. X plus 2 equals 0. And then we just solve. Add 10 to both sides. We get x equals 10. Subtract 2 from both sides, and we get x equals negative 2. Those are our two solutions. Those are the zeros of the function. Let's try one more. We have 2x squared plus 12x equals negative 16. If you go back and look at our steps, the first thing we have to do is move everything to one side of the equation. And so we're just going to add 16 to both sides. That's going to add to 0. What we're left with is 2x squared plus 12x plus 16 is equal to 0. Now all of these numbers are divisible by 2. And so we can factor a 2 out. We get 2 times x squared plus 6x plus 8 equals 0. And now x squared plus 6x plus 8 is what we need to factor. And so I'm just going to write this over here. Multiply the first and the last number. We get positive 8. Make yourself a box. Write the coefficient of x squared both times. Split up the variable x and x. And now we need two numbers that multiply to give you 8 and add to give you 6. And so 4 and 2. And so when we factor this, we get x plus 4 and x plus 2. Notice that I kept the 2 in front, and let's just keep the equation the same. Now 2 is not equal to 0. And as I was saying before, 2 has nothing to do with the solution to this problem. It's a common factor, so we were able to take it out. But what does have to do with the solution is x plus 4 and x plus 2. So we want to take each of those and set them equal to 0. If we say x plus 4 equals 0, subtract 4 from both sides, and we get x equals negative 4. We say x plus 2 equals 0 and subtract 2 from both sides, we get x equals negative 2. And so those are our two solutions to this quadratic equation. So, for some special cases of quadratic equations, we can use what's called the square root problem. This only works for quadratics where b is equal to 0. Okay? It doesn't have that middle term. So, for example, it should look something like ax squared plus c equals 0. And it's very similar to solving a linear equation, so we're just going to take the square root at the end. Remember that the roots can be positive or negative. We talked about that in the last section. And this is where those two answers come into play. So let's try this one. 5x squared minus 20 is equal to 0. What we want to do is we want to solve for x squared. We want to get x squared by itself. And so we're going to add 20 to both sides. And you get 5x squared is equal to 20. And we want x squared by itself, so we want to divide by 5. And when we divide by 5, we get x squared is equal to 4. And now we can take the square root of both sides. The square root of x squared is just x. And the square root of 4 is 2 and negative 2, plus or minus 2. And so there's our two solutions. Let's try another one. 6x squared is equal to 36. Once again, we want to get x squared by itself. And so we'll just divide both sides by 6. We get x squared is equal to 6. Now we want to take the square root of both sides. The square root of x squared is just x. The square root of 6 is a decimal, goes on forever. So we're just going to write this as the square root of 6 and negative square root of 6. If the square root will give you a decimal number, don't use the decimal. Always write it as a square root. We have another here, x squared plus 25 equals 0. We're going to subtract 25 from both sides. And we get x squared is equal to negative 25. If we then take the square root of both sides, we get x equals, well, now we have the square root of negative 25. And we just talked about that in the last section. But the square root of negative 25 is the same thing as the square root of 25 times the square root of negative 1. And so we get plus or minus 5 times I. And so when we take the square root, we get plus or minus 5 times I. Or if you want to put it in the computer, 5I, comma, negative 5I. Finally, the solution to a quadratic equation gives you the zeros of the function. Okay? It gives you the x value where the function equals 0. And because it gives you the x value where the function equals 0, what you get is the graph as it crosses the x-axis. It gives you the point on the graph where it crosses the x-axis. Note that x-intercepts are always written as ordered pairs, so you get an x value and a 0 after it. Zeros are just the x values. The problems on the computer will ask for both. When we're talking about quadratics, solutions with real answers will cross the axis at those points. Okay, so if we don't have any i's in our solutions, then what we're doing is we're finding the points where the graph crosses the x-axis. If we do have i's in the solutions, then the understanding of that is a little more complex. So to determine the x-intercepts of the graph, just look for where the graph crosses the x-axis. Okay? If you're given the function, you could also set it equal to 0 and solve to determine the x-intercepts. Well, let's just say we have this picture and we want to find the x-intercepts of the graph and to start determining the zeros of the function. We don't have to know what the function is. Let's just look for where this thing crosses the x-axis. Well, here it crosses at x equals negative 1. And then it also crosses at x equals positive 4. And so if we want to find the x-intercepts, the points where the graph crosses the x-axis, then we're going to get the point negative 1 and 0, and 4 and 0. Remember the x-intercepts are points, so we just want to know what are the points there. Well, it's negative 1 and 0 and 4 and 0. Now, if we want the zeros of the function, then we just want to give them the x values. So, the zeros, x equals negative 1 and positive 4. So don't get those two confused when you're working the problems on the homework. X-intercepts are points. Zeros are just values. So at the end of this lesson, we're able to solve a quadratic equation by factoring and using the square root property. They should be able to find the x-intercepts of a graph.